Hi, thanks so much for joining this webinar. I will show you how we can use special tricks with the land to collect and save water. And this is a pre-recorded webinar, so I am live with you in the chat box whilst this webinar is played live. You can ask questions at any time during the presentation by typing them into the chat box. I will do my best to answer as many of your questions as possible, and if not, I will make a separate Q&A video. We will learn today that water scarcity can be turned into abundance, which can help not only the plants and animals, but can also make our backyards, farms, and neighborhoods better and safer. This webinar applies primarily to humid landscapes, and there are two things we need to start with. Firstly, we need to observe and judge the current state of water movements. And secondly, we need to understand the soil and what happens when it rains. Once we go through this, I will show you basic permaculture water design concepts. So in relation to the first point, it will really help you out if you observe the landscape when it rains. You can observe water flows, you can see where the water collects, or where it drains away, or where it drains from, and what is working and what isn't. And take notes. Just so you know what to watch out for, here are examples of things that don't work. So road erosion. This is the force of flowing water that washes away the soil from the roads, causing erosion and creating deep channels. And this can make roads uneven and unsafe for vehicles and equipment. So flooded and damaged roads make it challenging for farmers to access different parts of the farm. And this can disrupt routine farm operations, including planting, harvesting, and transporting crops. And another example is bridges and culverts. So small bridges and culverts are designed to channel water under the road, and they are put under immense pressure if they are not adequately maintained, or if the rainfall exceeds their capacity. They may be damaged or washed away. So, example of things that you may like when it rains excessively is when water gathers in a spot where you don't envision placing structures or a garden. So potentially you may notice a place of a future pond, but it's important to investigate why the water gathers in this spot. It may be because you have compacted soil, or it may be because some unwanted soil disturbance it's happening that will need to be fixed. So I hope so far so good. Let's move on to the second point, which is understanding your soil and what happens when it rains. So when it rains, gravity is the main force that decides how water moves around in nature. Water tends to take the easiest route. So picture a surface that lets water soak in evenly. The water will flow straight down, perpendicular to the shape of the land, meaning at 90-degree angle to the contour line. But gravity is not the only force at play. Once water soaks into the soil, it also moves considering how porous the soil is, and also because of the capillary action, which is a phenomenon in which liquid spontaneously rises or falls in a narrow space. Let me explain by giving this example. So when rain falls or there is water around, it moves downhill because of gravity, and also it gets absorbed by the ground. And the way water behaves in the soil depends on things like how much space is in the soil and how sticky or slippery it is. So when rain falls on soil, it might not soak in right away. This is because water molecules like to stick together due to their charges. Picture it like tiny magnets attracting each other, creating something called surface tension. This can slow down water from soaking into the dry soil. But once soil is wet, though, the water can get in more easily, and capillary action can now take place, drawing water into the soil. Now, when water gets into the soil, it can stick to soil particles, making the soil wet and sticky. And this stickiness also makes the soil flexible. Like when you can mold wet clay, but not dry clay. It's because of the water forming layer on the soil particles. So water in the soil doesn't just sit there, it can move around. And smaller particles in the soil, like clay, can hold on to water more tightly than larger particles like sand. And capillary action is stronger in smaller soil particles that have tinier gaps between them. And clay, for example, has smaller gaps, making its capillary forces more powerful in moving water compared to soil with larger gaps like sand. And if you have a layer of clay on top of a layer of sand, the clay layer will get soaked with water first before the water drains into the sand layer. And the capillary force in the clay holds onto the water so tightly that it doesn't easily flow down into the sand. Only when the clay layer is fully saturated does gravity take over and the water flows into the sand. So if the ground is made of a material with more pores like sand, gravity plays a bigger role in moving water. If there is sand on top of clay, water will flow down until it reaches the clay. And once it gets to the clay, the water can be pulled right into it, whether or not the sand is fully soaked. So, what does it mean and why it matters? Soil isn't the same everywhere, and the ability of water to flow through the soil is called hydraulic conductivity, can be different in different parts of the soil. So it's not just about the size of the gaps between particles, but also how connected they are. It's quite normal for some parts of the soil to not let water through very well, which can cause puddles or runoff when it rains a lot. This can also happen when soil gets compacted from activities like tilling, overgrazing, or deforestation. So does it mean you have a big problem if you have sandy soil that lets water to run off too quickly, or if you have heavy clay soil that is too compacted and doesn't infiltrate much water? Does it mean you have to move somewhere else where the soil is nicer? Well, in gardening, we hear that the best soil is loam, so the perfect mix of sand, clay, and silt. But to answer this question, let's look again at the information we've learned. We know that hydraulic conductivity matters. What also matters is the arrangement of soil particles. What's important is that channels between the pores can form naturally as soil particles align or through biological activities like soil shrinking and swelling and when humans interact with the soil. But fortunately, this is not the full story about water movement in soil. You see, the roots of plants, both big and small, shape the soil by pushing through it and creating new paths. When old root hairs die, they leave gaps and organic material for other living things to use as food. So substances released by plants, fungi, and microorganisms help stick soil particles together, giving healthy soils a crumbly structure. So insects like ants and termites, as well as worms, also play a big role in shaping the soil. So the more vegetation, organic matter, insects, and microorganisms, the better. It's because these soils allow water to soak in and can hold on to moisture, making it available for biological processes. So if soil conditions on your land are less than ideal, you don't have to move anywhere or buy the soil because you can vastly improve the soil, whether it's sandy or clay, simply by adding organic matter and planting appropriate plants. But just as we can improve the soil year after year by applying sustainable gardening techniques, we can also degrade the soil. For example, soil can get compacted in various ways. For instance, too much grazing by animals can squish the soil and remove plant cover when the soil is bare. It's vulnerable to erosion that forms crusts on its surface, and this results in water puddling when it rains. And deforestation or clearing trees also strips the land, creating crusts that increase runoff and puddling while reducing water absorption. And in tropical areas, this can cut soil's ability to let water through by 50%. That's why agricultural practices developed in Western world kill the soils in tropics much faster. We'll talk about sustainable land practices in tropics in another webinar, by the way. So tilling or plowing the soil breaks its crumb-like structure, making it harder for water to soak in. And some soils might show an initial increase in water absorption after plowing. But over time, rain breaks down the soil particles, forming crusts, and it reduces water absorption. So let's talk about plants for a brief moment. Having plants on the soil is like having a good cover. It prevents soil crusts that can stop water from getting in. And even though some water evaporates from plants, the soil stays healthy and water is still available for living things without any cover. The soil structure can be damaged and water is more likely to evaporate. That's why it's so important to look at all aspects of land management holistically. It's not enough that we fix erosion or increase water storage. It's about everything: plant selection, placement, soil improvement in terms of structure and fertility. And that's why farms designed in permaculture way avoid or diminish the problems associated with the land. So, what do we consider when deciding water permaculture system? When designing a system, we always start with water and then we design other systems around the water. Obviously, if there are structures or access already present on site, we try to harmonize water with these elements as much as possible. It can be sometimes tough, but a good permaculture designer can predict certain problems and tell you how you can avoid them. So before we look at specific design ideas, let's look at the question why. Why we need the good water system or water harvesting system. When it rains, not all water gets infiltrated. In fact, it's usually a smaller percentage that gets soaked into the soil. And most of the water is, as we've learned, cannot be absorbed because the soil is either too dry or too wet or too compact. So water follows the path of least resistance, downhill to the valley, to streams and rivers, and to the ocean. And sometimes, even after big rain, there could be still some water scarcity. I've read various opinions on the internet about permaculture practices, and sometimes people are under the impression that permaculture water harvesting systems steal water that could otherwise fall to lower areas. Well, do they? Think about it. When it's raining, the water flows with speed downhill, and we know that this water is not infiltrating to the soils quickly. And as a consequence, water is rapidly lost to the river, which in turn flows to the sea. And in effect, water is quickly lost to oceans. But what happens when we install water harvesting systems higher in the landscape? Well, groundwater levels can increase once the landscape uphill is abundant in water. And what happens to the surplus? The surplus water overflows. But where? It overflows steadily downhill and to the valley, also with help of tree roots. So you see, there are different types of water flow in the ground. We have overland flow or runoff, which happens when rain is falling faster than it can soak into the soil. We have saturated overland flow occurring when water temporarily reaches saturation and then escapes to the surface, like streams in areas with high water tables. And we have through flow, which is water flowing near the surface. And finally, groundwater flow is the water moving in the big underground storage. So there is no stealing. We just prolong the time in which water is available in the landscape. And the surplus water, with the gravity force, gets pulled down anyways. So lower landscapes get this water eventually, but in nice steady doses, ensuring better water infiltration down in the valley. So it's a very safe and effective distribution of water. Imagine how many floods would be prevented if we managed the water appropriately. Not only lower landscapes, but also higher. Imagine if cities were designed to capture road runoff, and this water, instead of overflowing to one place that gets clogged, that water would be distributed in a smart way to areas with vegetation, like trees and parks and our gardens. So each place would receive a nice, steady flow of water. Another really interesting thing is that we can multiply the amount of rain that comes onto the land if we have water harvesting surfaces like roofs and roads. It's now no longer about the amount of rainfall that hits the soil. It's about gathering more water than the original surface of the land we're dealing with. For example, here's the picture showing a very lucky person cultivating the land all around the hill. They can put a diversion drain around the contour of the land that collects water just sliding off the hill. Remember, water flows at 90-degree angle to contour line, so that's why contour farming is so efficient. And that's why your garden rows would get more water this way if you designed it along the contour lines. So the diversion drain is connected to the pond, and the pond harvests water for later use or for immediate use if necessary. For example, if it rains a lot, the pond pipe is open and flows to other diversion drains or other air forks and is distributed to where it's needed. Another example is on our homestead. So we collect rainwater from the road, which collects rainwater from the hill above. So I calculated that the road gathers rainwater from about 3 hectares, which is 6 acres, and this water flows to our land. You see how much water you can manage? Our open land, which we cultivate, is only 1 hectare, 2 acres, but we get overland flow from 6 acres. That's so much more than if you had no collection area and you relied only on pumping up groundwater for irrigation, depleting the groundwater resources. So in permaculture, you always look at reviving natural ecosystems. So as a consequence, groundwater reserves get replenished, especially with swales, which we'll talk about in another webinar. And the surplus overflows downhill in a safe way with the help of gravity and tree root systems. The need to import water on permaculture farms is therefore vastly diminished. So tell me in the chat, does it feel it's a sustainable way of treating the land and precious resources or not? So to summarize, managing water effectively on land involves understanding how water moves through different soils and using that knowledge to plan and implement smart water systems. Okay, let's move on to some examples of permaculture design in a humid landscape. You may have heard about the key point and its importance in permaculture water system. In very simplistic terms, it's where contours start to spread and where the hill transitions from convex to concave. And water harvesting systems are often recommended to be carried out below the key point because the areas above it are more erosive. So the key point helps decide where to start collecting water, but also suggests where to consider planting a forest. So the land above the key point should be forested, and the land below the key point can be used for things like growing crops, having orchards, or creating pasture areas. So now imagine the forest on this land starts at the highest point and goes down to the key point. So forested area is creating a thermal belt, and it has a very nice feature. So frost moves across the top of the ridge and sometimes rolls downhill. So frost moves over the trees, pushing warmer air down between the frost above the key point and the valley floor below. So there is a thermal belt. This warm area just below the key point is where people might choose to live. It's a great place to start early in spring. It's also the last area in autumn where plants are productive, so it has a long growing season. If you walk on a cold night from key point to the higher areas, you will feel the temperature drop. But with a forest above the key line, even in the snow, there is a warm flow of air within this thermal belt. If this hill happens to be facing equator, you gain even more warmth during the sunny days, vastly extending the gardening season. So it's a very good idea to dedicate a space for these water systems at key point. Now, let's move on to the lower slopes. As the grade decreases, the amount of water stored per soil moved starts to increase. This means that your first dam at key point won't be big, but it's often critical to install for irrigation downhill. Any earth storages we make lower down are very cheap. That is, the flatter the floor that we are flooding, the more water we get for money spent. It doesn't matter where that is, on an open field or on a ridge or in a valley floor. So when we are looking to large storage, we walk the valley floor and find where it levels. We can come back to our observation principle and notice when it rains. Where the water speeds up, that is where we are going to have to move a lot more soil. Where it's moving slowly, that could be a floor of our pond. Where it starts to speed up, that is where our dam will go. Now I want to show you a photo taken a year ago. We got this big snow event, 0.5 meter, about 2 feet in 24 hours. After a few days, when the snow started melting, you could see these lines of water movement. This perfectly shows the shape of our landscape without looking at the contour map. So water moves at 90-degree angle to contour lines. So the imaginary lines perpendicular to these water lines are our contours. Isn't that great? So what I did last year, I double-checked if we positioned our water harvesting features correctly in the landscape. So if the water lines hit our swales and pond at 90-degree angle, that meant we did okay. Now we move to production dams. So these are where we get the most yield from water. They are like the VIP spots for fish, ducks, water chestnuts, crayfish, and all those little creatures. They thrive in these low dams because there's flow of nutrients, like dissolved solids. Even if the water looks crystal clear, it might be carrying some important stuff. Sometimes there is more stuff eroded from the hillside in clear water than in dirty water. And the cool idea here is to catch these nutrients in a biological net. So we want to grab the good stuff, the nutrients, dissolved solids, calcium, etc., without using fancy high-tech equipment, and then get these goodies back onto the land. So here is a cool trick. We can put fodder plants, algae, mussels, and snails in these ponds. They will soak up that calcium and fix it. So you're essentially using these little biological machines efficiently, working at the molecular level, straining out the nutrients before they leave your property. So the ideal setup begins with clean, high dams, gradually dirtying the water with manurial nutrients. So you can keep your ducks on a slowing flow onto some of these ponds. You can wash your animal manure into some of them. And then you can start putting this water through your wetland plant systems. Getting high plant growth that you can harvest, you can run water through other systems and let it become clean again. So the idea is for the water that finally leaves your property and that goes into streams to be a clean water again. And you might think that you will need a massive land for all these systems, but Bill Mollison said that actually you don't need much room. In a step-by-step manner, you can have a sequence of mini ponds and other water harvesting systems, like a mini pond on the highest elevation, a mini duck pond, mini wetland with bamboo filtering, fairly clean water running out. So to sum up, let's go through it again. We start by collecting clean water at the highest point for domestic uses. We then add nutrients to water as it runs through our plant system. Afterwards, we let it flow into a fish pond, carrying food from the natural productivity system. We can also irrigate our crops with it and let it flow to the biomarsh. Once the nutrients are converted to biological farms, we release clean water back into the stream. This entire process can be achieved within a vertical drop of just a few feet, moving from zone to zone. So we are not necessarily talking about massive systems. Even smaller setups can work. So in a nutshell, managing water in the landscape involves understanding soil particles, water dynamics, and the specific characteristics of different sections of the slope. It's like creating a balanced and resilient ecosystem where human activities work harmoniously with the natural landscape. I hope you asked plenty of questions. You will receive the answers either in the chat, in the comments section, or in the Q&A video. Thank you so much for your attention, and I will see you in the next webinar. Bye.